Anthropic just dropped 2 new models. And not only that, they dropped something completely unique, something that no other model provider is offering right now: computer use. What does that even mean? I'm going to explain everything right now. So here is the announcement blog post. We have 2 new models. And just a few months ago, they released Claude 3.5 Sonnet, which was their frontier model, better than even Claude 3 Opus, which is their largest model. And now we have a brand new version of their best model. And apparently it's even better at coding. And if you've been following the AI landscape at all, you know that Claude is already known as the best AI coder. They also released Claude 3.5 Haiku, but it's their half-step version of the small model. Very similar to how we went from Claude 3 Sonnet to Claude 3.5 Sonnet. Now we have Claude 3.5 Haiku. And right at the very top of the blog post, it says, the upgraded Claude 3.5 Sonnet delivers across-the-board improvements over its predecessor, with particularly significant gains in coding, an area where it already led the field. And they also announced computer use, which is insane. It allows you to let Claude control your computer, and I'll explain that in a little bit. So first, let's look at the benchmarks. Here's Claude 3.5 Sonnet, the new version, GPT-QA, MMLU Pro, and as you can see, nearly across the board, it is the best model compared to all of the frontier models from the other model providers. Now, there's one big exception here. You could probably tell it is missing O1. Meaning they are not comparing themselves against the O1 model. And I think the reasoning is O1 takes time to think. And this model is more comparable to the 4.0 model from OpenAI, which doesn't think, it just gives you the first thing it predicts. Now, let's look at a couple things. First, Claude 3.5 Sonnet is the best model across the board, which I already talked about. The other thing to note is its improvement over Claude 3.5 Sonnet, quote unquote, old. So on graduate level reasoning, GPT-QA, it went from 59% to 65%. MMLU Pro, which I think is probably the best benchmark, is 75% to 78%. Now, the math problem solving, it did have a substantial improvement from 3.5 Sonnet to Sonnet New, 71% to 78%, but Gemini 1.5 Pro still leads the pack and has a pretty substantial lead, actually, at 86.5%, compared to number 2, which is the new Claude 3.5 Sonnet model, 78%. Next, high school math competition, 16% using zero-shot chain of thought, and that is much better, nearly double Claude 3.5 Sonnet old. And then we have agentic coding, which is incredibly important, and I love that they're starting to include agent-based benchmarks. So agentic coding, 49% as compared to the previous version, 33%. And agentic tool use, as you can see here, a pretty substantial improvement as well. And here's Claude 3.5 Haiku, which in this blog post, they say is better than Claude 3 Opus, which is their massive model. So this tiny model is now better than their previous massive model. All right. But let's get to the juicy stuff now. Computer use. What does that mean? How does it work? Does it work well? Let me tell you about it. So it's available today on the API, which means developers can use it to essentially allow Claude 3.5 Sonnet New to control their computer. You can tell it what to do in prompt form. For example, I want you to fill out this Excel with all of this other data that can be found in a screenshot. And you pass it to the API, and it tells your computer how to operate. And this isn't the first time computer use has been attempted. No other model provider has tried it, but there have been other projects that have tried it, such as Open Interpreter and a number of other open source projects. And they've worked to varying degrees. And Anthropic says this is experimental, it does fail, and you shouldn't rely on it for critical use cases. But it's awesome nonetheless. And so rather than me trying to explain it, let's just watch the video.
We're going to be going through a quick demo today. In this fictional demo, a customer, in this case the Ant Equipment Company, has come to us and asked us to fill out a vendor request form. The data I need to fill out this form is scattered in various places on my computer. What we're going to do is ask Claude to look at the spreadsheet, check if Ant Equipment is in there, and if not, move over to the CRM and try and find some more information there. Once it has this data, Claude's going to then fill out the form for us and hopefully transfer the information across to the vendor form. The first thing that's going to happen is Claude's going to start taking screenshots of my screen and quickly realizes that the Ant Equipment Company isn't actually in the spreadsheet. So the first thing it does is it swaps over to a CRM and searches for the company we're interested in. Luckily, we get a search match, and Claude then starts scrolling through the page, looking for all the information it needs to fill out this form. Claude then autonomously starts transferring the information across without me having to do anything, and goes through the steps and fills out all the information needed. And then submits the form. This example is representative of a lot of drudge work that people have to do. This is available in the API. We're excited for people to try it, and we should expect things to get a lot better over the coming months.
All right. How incredible is that? We now have an endpoint that is provided by a leading model provider that is used to control your computer. I've talked about this a lot, but really the interface of the computer seems like it's just going to melt away over time. There's really no use to an interface when you can just talk to AI and get exactly what you want. And in fact, the interface will likely be created in real time at the moment you need it, and nothing more. It'll just present anything that needs to be ingested visually to you in real time, and then it'll just disappear. Just in time interface. And this is just a baby step toward that vision. So here's the documentation for it. Again, you can use it right now, and it says it's a beta feature. Use a dedicated virtual machine or container with minimal privileges. So it's really trying to protect your sensitive information. Avoid giving the model access to sensitive data such as account login information to prevent information theft. Now, how is it supposed to do anything useful if it can't have your authentication information? We'll see. Limit internet access to an allow list of domains to reduce exposure to malicious content. Ask a human to confirm decisions that may result in meaningful real-world consequences. And so this works very similar to how Open Interpreter and other projects have worked. You take a screenshot of your screen, you pass it to the model tries to understand what's on your screen, it takes your prompt, your instructions for what it needs to do, then it figures out what it actually needs to do. And to do that, it comes up with coordinates, and it basically maps coordinates to your screen and then moves the mouse, clicks, types, whatever you need. But from what I've seen so far from other projects, the coordinate system doesn't work all that well. And so as part of the computer tool, you send screenshots. Obviously, it has to be able to see your screen. And interestingly enough, Anthropic actually gives you the tool definition here. So use a mouse and keyboard to interact with a computer, you take screenshots. This is an interface to a desktop GUI. Some applications may take time to start, the screen's resolution, the number of screens, and so on. So all of this is already in there. And here's the schema for it. So you have the type, cursor position, mouse move, left click, drag, right click, middle click, screenshot. So it is a pretty simple API to work with, but you do have to give it a containerized environment, which is more or less straightforward. And of course, you could work with Claude to get that working as well if you want to. So it seems really cool. I'm not going to test it in this video, but if you want me to test it and you want me to make another video specifically testing the computer use functionality, let me know in the comments below. And they released a blog post about why they actually created it and how they did it. So let's read a little bit about that. So the latest version of Claude, when run through the appropriate software setup, follow a user's commands to move a cursor around their computer's screen, click on relevant locations, and input information via virtual keyboard, emulating the way people interact with their own computer. And I've actually seen a couple other projects which have made virtual computers that are much easier to interact with by an artificial intelligence. So right now we're using this grid system, this coordinate system. From what I've seen so far, and I haven't tested this, it just doesn't work all that well. So why is computer use important? Well, to me, it seems like this middle ground, very similar to why robots are built with the humanoid form factor. It's because the world is built for humans. So the humanoid form factor has the most generalizability, and that is why we're seeing this proliferation of all of these humanoid robots. And similarly, computers were made to be used by humans. So there's a mouse, there's a keyboard, there's a graphical user interface, you move the mouse, you click on things, you type things, and right now, there isn't an advanced operating system that is really built for large language models to operate. And that's why they're doing this computer use functionality now. Now, I believe in the future that's going to change. We're going to have operating systems that were specifically built to be used by AI. And in fact, I've already covered that in previous videos. There's a couple nascent projects, but nothing substantial quite yet. Enabling AIs to interact directly with computer software in the same way people do will unlock a huge range of applications that simply aren't aren't possible for the current generation of AI assistants. Yes. So basically, unless everything has an API, and not everything has an API, we need a way to interact with it the same way that humans do. And that's why I think this is a short-term, maybe mid-term solution, but still very powerful today. And if we are to reach this really ambitious vision of having agents that can perform a vast array of tasks on my behalf, on your behalf, then they need to be able to interact with your computer and all of your personal accounts, really. And so that's why I've said it before, I'll say it again. Google and Apple have a huge advantage that is really only theirs to lose because they are so deeply integrated into everything we do. On our phones, we basically do everything through either Mac OS, iOS, or Android. And of course, Windows as well. But Windows doesn't power mobile phones anymore. Here, they talk about the research process and the fact that a lot of their research and multimodality allowed them to create this computer use functionality. And that makes sense because they have to be able to read your screen and understand what's on your screen and then interpret that and convert it into actions, which then you execute against that same UI. Now, here's the important part and why I've said a few times in this video that the coordinate system hasn't worked well in the past. When a developer tasks Claude with using a piece of computer software and gives it the necessary access, Claude looks at screenshots of what's visible to the user, then counts how many pixels vertically or horizontally it needs to move a cursor in order to click in the correct place. Training Claude to count pixels accurately was critical. Without this skill, the model finds it difficult to give mouse commands. But again, it is essentially just guessing. It is looking at the screen and trying to guess how many pixels it should be moving. And as I've said multiple times already, that's really hard to do. Now, the next video I want to show you is a really unique and kind of weird approach to coding where you're giving Claude access to your computer and it's doing the coding for you, but rather than with a nice interface like Cursor where you're actually doing all the clicking and just allowing the model to insert the code and use tab completion, it's doing everything. It's actually opening up VS Code, it's pasting the code, it's running the code, seeing the error, iterating on the errors, and let's watch.
I'm Alex. I lead developer relations at Anthropic, and today I'm going to be showing you a coding task with computer use. So we're going to be showing Claude doing a website coding task by actually controlling my laptop. But before we start coding, we need an actual website for Claude to make changes to. So let's ask Claude to navigate to Claude.ai within my Chrome browser and ask Claude within Claude.ai to create a fun 90s themed personal homepage for itself. Claude opens Chrome, searches for Claude.ai, and then types in a prompt asking the other Claude to create a personal homepage for itself. Claude.ai returns some code, and that gets nicely rendered in an artifact on the right-hand side. That looks great, but I want to make a few changes to the website locally on my own computer. Let's ask Claude to download the file and then open it up in VS Code. Claude clicks the Save to File button, opens up VS Code, and then finds the file within my Downloads folder and opens it up. Perfect. Now that the file is up and running, let's ask Claude to start up a server so that we can actually view the file within our browser. Claude opens up the VS Code terminal and tries to start a server. But it hits an error. We don't actually have Python installed on our machine. But that's all right because Claude realizes this by looking at the terminal output and then tries again with Python 3, which we do have installed on our machine. That works. So now the server's up and running. Now that we have the local server started, we can go manually take a look at the website within the browser. And it looks pretty good, but I noticed that there's actually an error in the terminal output, and we also have this missing file icon at the top here. Let's ask Claude to identify this error and then fix it within the file. Claude visually reads the terminal output and then opens up the find and replace tool in VS Code to find the line that's throwing the actual error. In this case, we just ask Claude to get rid of the error entirely, so it will just delete the whole line. Then Claude will save the file and automatically rerun the website. So now that the error is gone, let's go take a final look at our website, and we can see that the file icon has disappeared and the error is gone as well. Perfect. So that's coding with computer use and Claude. This took a few prompts now, but we can imagine in the future that Claude will be able to do tasks like this end to end.
Let me show you another really cool example of computer use now. Let's watch this video.
I'm Pooja, and I'm a researcher at Anthropic. I'm going to show you a simple example of computer use today. My friend's coming to San Francisco next week, and I want to take him to do some touristy stuff. I think doing a sunrise hike with a view of the Golden Gate Bridge never gets old. So I'll ask Claude to figure out some logistics for us. I'll ask Claude to find a good place to see the sunrise, to help me figure out timing logistics, and help drop a calendar invite so I remember when I have to leave. It's opening Chrome, going to Google, searching, and it looks like it's found something. Great. So how far away is the location from my place? It's opening maps, searching for the distance between my area and the hiking location. Cool. So now it looks like Claude is searching for the sunrise time tomorrow. And is now dropping it into my calendar. And populating it with some details. And great, it looks like Claude did it. This is a simple example, but we're sharing computer use early to learn from what people build.
But as I said multiple times already, it's not perfect. And in this next video, you're going to see the Claude model basically take a break from what it was instructed to do to go research Yellowstone National Park completely on its own. So let's watch. So that's it for today. I'm going to record a separate video fully testing Claude 3.5 Sonnet new and the benchmarks that I usually test against, but that'll come in a new video. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.